Welcome, and in this series of screencasts, we're going to talk about 55 new features in Java 7 that you probably didn't hear about. You may have heard about them as they go on. We're going to do this in a series of probably 4 screencasts. Normally when we do this presentation, it takes about 55 minutes, 55 slides. We do this in a very quick format. We go through the slides, and when the minute is up, we go from there. But when we take a look at this, the PRD for Java 7 had almost 2,000 changes. And we're going to talk about 55 of the better ones that are in there. So we're going to start talking about the changes that came in Project Coin. And of course, the first change that we talk about is binary literals. And binary literals are a new piece that was added in. Very simple type of thing where you can add binaries to a mask, bringing in your literal in there to an int or to a short. Makes it very simple to add those binaries in there. You couldn't do this once before. So, and as you can see in the case here, we all know that whenever we can use binary literals, we could create things like happy faces. So, kind of a cool feature there for binary literals. The other feature that was in Project Coin in JDK 7 is underscores in numeric literals. So following along the same sequence here, and now it allows you to be able to put these underscores in, and again makes this very easy to be able to read this. I don't know about you, but when I would take a look at that first line where we're doing a mask, if we were reading that as just one group of letters without the underscores in there, it becomes very difficult to read that environment. Take a look at a credit card. We can see where it's much easier to see that. We can look at the Social Security number, how that comes out there. It makes a lot of sense to be able to do that. The thing is that you have to do these things in the right location. We can take a look at some of the invalid ones that are down here. So, you know, putting an underscore in exactly the wrong place right before, like when you're dealing with a Social Security number before you're defining the L, doesn't work. Strings in switch is one of the next pieces that's kind of an interesting new addition that's in JDK 7. And it gets a lot of wow factor whenever we do presentations in this area. You would think after 16 some odd years that Java was out that we would finally figure out that strings are literals, especially when we're dealing with switch cases here. And this just makes the code much easier to write, but not only does it make the code easier to read and to write, but it also makes it more efficient. It's a much more efficient bytecode than if we were just doing if-then-else statements, and certainly, much more productive, especially if we're dealing with several thousands of these. In this particular case, we would only have 12, but even with 12, there's some performance improvements that we would see there. Turning now to the next one, which is automatic resource management. So one of the problems that you would have when we really want to copy from one byte buffer to another byte buffer, you can see the simple code which is included right in this area here. And that's basically all that we really want to do. But in order to handle that before JDK 7 came along, we probably had to create almost 5 to 10 times that amount of code to be able to handle that. And so what we've added now is this new try with resources, as we kind of say, automatic resource management. Put in the new try block, say the input stream is this, the output stream is that, and then they'll automatically be closed for us. And that auto-closable is something that was a new super interface that was added, and they went back and actually retrofitted all of the JDK to where that could be included. In fact, there's even things like JDBC 4.1 were included in there. You can use that if you want to as well, and the great advantage to you there. Now, suppress exceptions is an output of some of the stuff that comes with that automatic resources, because what would happen if you had a problem with closing in and you had a problem with closing out in the previous thing that we saw there. And so the suppressed exceptions means that even if you get 2 types of errors that'll show up, you'll be able to get both of them now. And that's something that we weren't able to track before, because we could only tell if there was one error that had occurred, and now you'll be able to find out which ones are suppressed. You can return the throwable on those, or you can add suppressed to a throwable. Multi-catch. So try with multi-catch is a really nice new addition in. It makes it a lot easier to understand the code. We don't have to clutter it up as much. In this particular case, in the first catch, we're going to do a class cast exception on E, and we'll do something clever. But for the rest of them, an instantiation exception or a no such method exception or an invocation target exception, if we're doing a generic action, in this case just logging E and then throwing E, we can use all three of those. And what's nice about this is what E is going to throw is either an instantiation exception, a no such method exception, or an invocation target exception. So it's a nice new feature that has come in. Will reduce the amount of code that you had before, and a simple addition there. Now, more precise rethrow. Prior to Java 7, if we looked at this code that we have here, so throws, we have public foo string bar, throwing the first exception or the second exception. Try some code, may throw both a first and a second exception. So, prior to JDK 7, this code certainly wouldn't compile at all. The types of the throw would have to match the types of the catch, and foo would have to throw an exception. It can't throw a specific first or second exception. So now, because we can catch that either first or second exception, we can just say, hey, catch the exception, throw the exception, and you tell me what it's going to be on the backside. So JDK 7 added support for this as long as the try blocks all exceptions. All the exceptions are in the throws clause. But take a look at it, give it a try. Diamond operators. So diamond operators are a nice piece here. It took me a while to be able to figure out why they called it diamond, and obviously because it looks like a diamond. And what we're doing here is using the left-hand side of the operator to equal what's on the right-hand side of the operator. So we should only have to define this once. And it's especially useful when we're trying to go through and we have these long definitions or we have to make changes. It makes it much easier in this environment. Now, this is not simply, it's more complex than just having the compiler perform some string substitutions. For certain cases, the type inserted is not represented by the string in the variable declarations. Wildcards are maybe a good example of that. And the compiler has to infer the type parameter for the information from the type parameter of the variable declaration. So there's a lot of stuff that happens under the cover with the diamond operators. Finally, the last one that we have here is the Vararg warnings in Erasure. So let's take a look at this code a little closely. And as we get an unchecked generic array warning, there's a heavy use of static method as list from arrays class defined as a public static list as list, and it returns a fixed size list backed by a specified array. Now let's go back to this code here and take a look at it. We're defining 2 months in 2 languages, one of them in English, one of them in Italian, and they're returning a list of strings. Now, of course, when we call arrays as list with January and February, in this case it seems to be an array as a list of strings of a list of strings. And we expect to get a result of a list of strings, and that's what's expected based upon our type of definition here. So why are we getting this warning? Well, what's happening is this generic type is instantiated in Java, and the let me back up here for a second so you can take a look at this. And this generic type is instantiated in Java. The compiler removes all the information related to the type parameters and the type arguments within the class or the method. And when this happens, it was primarily done to maintain binary compatibility, before we actually had generics. But basically what's happening here is we're expecting to return a list of question marks, and what happens is we lose the string definition in there. So if we want to get around this, the way we could do that is use suppress warnings, or we could use safe Varargs. And I thought it was kind of cute when I was interviewing Joe Darcy on this, or actually when he was doing his Christmas greeting, he said, "May all your Varargs be safe." Well, that's all that we have for this particular session of these 55. When we get back next time, In the next production that we're going to do this, we'll probably cover NIO2, and then we'll continue on, do some stuff with concurrency APIs, and then look at a variety of smaller type of changes that got into the JDK 7.